is that M20 is 16.3622. And using the value of the integral that we got from Math 9, which we weren't supposed to know about, this is off by only like 0.09. And it's off by 0.09 using only 20 subintervals, right? And also, do you feel that computationally this is no harder than LRM or RM? Okay, so with more, so instead of just going more rectangles, if we use more efficient methods, we get a much better estimate with far less computational power and far less rounding error. Follow?
Couldn't it even be better if you just like averaged each subinterval?
Okay, more. More. Okay, last rule. I think we have time for this. This is actually working out. The trapezoid rule. Oh yeah. The trapezoid rule says, instead of approximating the area under each curve with rectangles, do it with trapezoids. Oh, by the way, since I know that you are a product of MCPS, you probably don't know how to find the area of a trapezoid, so let's just review that really quickly.
Okay,
Why
don't you just derive it every time?
I shouldn't have insulted you, nonetheless. The area is the average of the bases times height.
Do you know where I learned that?
Where?
Studying for the related limits.
Good. Good. Okay. So.
Because there is one problem with the book.
Good. So here's what we're going to do. We're going to take this function from 0 to 2. Boom. And now on each interval, we are going on each subinterval. We're going to make a trapezoid. So that's like 1/10, 2/10, 3/10.
Oh no, that's cool.
4/10.
Pretty legit TBH.
Yes, isn't it great that I invented this method? Okay, so the trapezoid that we make is like, you guys all seen it? It's like that one.
Wait, that's a trapezoid?
So you just connect the...
Doesn't it have to be like sloping?
No, because
one
parallel
definition.
Wait, actually though.
So like, wait, on each. What do you mean by sloping?
Like, don't the sides have to be sloping?
No, it's just two sides are
Wait, what?
Two sides aren't
Use it.
parallel.
Sujan, this is a trapezoid.
What?
All that matters is that
What would you have
exactly
called
what's
that
this is gonna blow your mind even more.
My third grade teacher was like me.
This is also a trapezoid. Save your family.
Don't do this.
What? Isn't that like the rhombus?
No!
That's like 2 and that's
Stop
like
it.
4. That's a trapezoid. Okay, good.
No.
Anyway, wait. Staying focused.
It's the shear.
What?
It's like the
Yeah, okay, staying focused. So these are all trapezoids. The bases of the trapezoid are like the heights of the function, right? And then the delta x is like the height of the trapezoid. Follow? Of course you do. So, what would T20 be? T20 would be, well, let's do it. What's the area of the first trapezoid?
F0.
Just go slow and careful. What's the area of the first trapezoid?
F0 plus
F of 0 plus f of 1/10 over 2, the average of the bases, times the height, which is 1/10. What's the area of the next trapezoid?
Just like 1/10, f of 1/10 plus
F of 1/10 plus
f of 1/5.
f of 2, I'm just going to kind of do this for pattern recognition purposes, times 1/10. Yeah? Can we keep the camera panning so we got this under control? And then, can I just throw in some dots? What's the last one going to be?
F of
19
F of
18/10.
I think 19/10
plus 20 over 10.
plus f of 20/10.
Really?
Mm-hmm.
Because you get the last.
Because you get the last one, right? The last one and move over.
Oh.
You gotta kind of think about 2 times 10. Okay. So, would someone like to make an observation?
No.
No?
-1. F of I minus 1.
So first of all, I have 20 terms here, which are 20 trapezoids.
So it's just like, it's just the...
No,
like the derivative, like because
derivative.
It's like 1
yeah,
to
because
20.
like the
Yeah,
closer you
f of
get,
I
the more
minus
it's like
1
instantaneous
plus
slope.
Oh, he's thinking some secant line stuff that's worth mentioning. Okay, wait. So what do we get? It can factor out a 1/2 for sure. Yeah.
Can also factor out.
I can also factor out a 1/10, which is like delta x, and then basically what's left?
Just
No. It's a little bit. You have to be a little bit more careful.
F of 0 plus 2.
Yes, June sees that the first value, f of 0, is used only once, right? So it's like I have f of 0 plus f of 1/10 appears as the height of one base of the first trapezoid. Wait, no talking. F of 1/10 also appears as the height of the next trapezoid, right? You with me on this, Jade? F of 2/10 appears once, and then again, right? So this is going to be 2 times f of 1/10 plus 2 times f of 2/10, etc. What's the last one which gets used twice? F of 19/10 plus, and then the last one is f of 20/10. So that is going to do it. That's going to give me T20. Okay,
That's
yeah.
a really nice way to do it.
Question?
Could you just
There are
write
2
that-
ways to do what? Fast.
Oh, I was just gonna say how to do it.
Oh, on your calculator? Just do it.
No, like how to write it.
Yeah, you
Oh, how to write it in a sigma thing.
It's like a 1.
Yeah, it's kind of annoying.
Did I mess up?
What happened?
Could you?
Did I mess up?
I don't know. Is
I'm
that
just
right?
asking if you're allowed to do this.
Yeah, that is right.
Oh, okay.
How'd you do it? Oh, Maya's just been doing it meanwhile in the background.
Oh.
What did you do?
Okay, so I did, I guess I could have just done 1/20th, but,
Okay,
I did
whatever.
1/10. So, 1/20th times, some sequence, and then, y-bars function, y1, of x over 10, plus y1.
Okay, bell gonna ring. I don't know, we still have 2 minutes.
1 over 10 plus x over 10.
Yeah, is someone seeing that it's actually just the average of L RAM and R RAM.
X.
Do you guys see that? Because look, every one of the f of 0 through 19 is getting used once, and every one of the 1 through 20 is getting used once.
Wait,
We're adding them up and dividing by 2.
could you just do like?
Effectively, this is just legit she goes with me. Yeah, I would actually, there's several different ways to do this on your calculator. I don't know what Maya's doing. She's hacking some weird thing that's working somehow via some weird formula. Did you just get it to work?
Yeah.
You can just like manually sigma the
I'm
T20.
literally like
You can manually-
just putting in what's
Like-
on the board.
Yeah, exactly. If
Right.
you take
That's
T20
exactly
and
what I
literally
mean.
just sigma that, like y of.
But then how'd you get the last 2?
Oh,
I mean like
no,
the,
what I'm treating
the one
that
that
thing as
actually
a whole
says
function.
the
Yeah,
one at the
like-
top.
Like the first one.
Oh, you just like typed that.
Yeah, so I'm doing
Oh, yeah, that
f
works
of
too.
x
Yeah,
plus
that works
f
too.
of 1/10.
Alright, so I mean I have another way to do this, but never mind. If you can figure that out, then we get this. Okay, so wait, last thing. Very important. Seems like not gonna have time for it actually. But this is the trapezoid rule. Do you notice the true value lies between? So the true value, this integral, actually is somewhere between M20 and T20. And there is a reason for that.
Trapezoid overestimates concave up functions.
Yeah, that one I think is straightforward. Okay, this function is concave up, and I could prove that, but I'm running out of time. But just intuitively speaking, if I have a concave up function, and we use, I don't know, how about like one subinterval, then what does using the trapezoid rule on this one subinterval give you? Well, does it just seem right? That if the true area is this stuff, then the trapezoid rule is going to give you an overestimate. Okay, so I'm relatively happy with that fact. That is a fact. I can actually prove. Actually, I have already just proven it. This is it. The reason is because, and this is one of those proofs that we skipped, but I mentioned it, which is that the secant, if you have a concave up function, the secant line lies above the curve. So since the secant line lies above the curve, then the trapezoid rule is an overestimate for
What's like interesting?
for that.
I'm
What's
thinking
less
of-
obvious
Yeah, the midpoint.
is that the midpoint rule
Is an underestimate.
is an underestimate for a concave up function. And I'll just draw the picture right now, but maybe I'll explain it more later. Or give me like 10 seconds. Actually, whatever. We'll do it later. All right, bye.
Bye.
Good.